Hello students, today we will start with the experiment number 2 for our network design lab. Okay, so if you go on a course page of network design lab NDL, right, so you will find out on the experiment number 2 assignment, right. So it is nothing but to design and configure a DHCP server using Cisco packet tracer, right. So for that prerequisite, if we see, right, for that particular experiment, right, so if you must know the word knowledge for basic concepts of networking, right, obviously, because if you DHCP, if you see, you need to configure DHCP server, right, so you must know all the IP addresses. There are different commands also if you wanted to configure this DHCP server through command line, right, through CLI, right. So for that, these particular networking commands and all that things will be required. Then IP addressing classes, obviously, because you need to provide some IP address range to this particular DHCP server, so that whatever the different end devices which are connected to this particular DHCP server, right, so it will be get automatically IP address from this particular server itself, right. Then exposure of Cisco packet tracer tool, obviously this we need to perform on the Cisco packet tracer, right, so that you must know what are the different components and how to do a simulation on this particular Cisco packet tracer, right. Then identifying of different internet networking devices icons, right, so you must know the difference between the icons of switches, routers, servers, end devices and all that things, right, because then and then only you are going to you are able to drag and drop on your workspace of your Cisco packet tracer, right. Then we have the understanding of the functionality of internet networking devices like switches, router, etc., right. So knowledge about these particular internet networking devices also you must know, so so it will be help you to create a topology for your DHCP server, right. So so that's why the functionality of each and every internet networking devices you must know, right. So then knowledge of OSI layers and its functionality with its advantages and disadvantages of network topologies as well, because we need to design a logical topology into this particular Cisco packet tracer, right. And for that you must know what are the different OSI layers are there, and what are the different component internet networking components are there for at which layer, right, you must know, right. And after that advantages and advantages of networking topologies, because you need to create an logical topology here, right. So for that you must know that already the concepts, right. So all these are nothing but the prerequisite for this particular experiment is concerned, right. And you know all that things we already covered in our prerequisite of your enterprise network design subject, right. So after that, if you see what is the problem statement over here for this particular experiment is concerned, right. So this DHCP is nothing but your dynamic host configuration protocol, right. It is a network protocol in which we will be use this particular DHCP server for automatically assigns then IP addresses, right, to the clients which are requesting for IP addresses, right, and which are connected to this particular DHCP server pool, right. So you know already that if you manually do or manually assign the IP addresses, right, but it is feasible for if you have a small kind of the network, 2 to 3 PC, 4 PC, 5 PC, it is fine with it, right. But if you have a large network, right, if you have thousands and hundreds of the PCs over your network, right, and if you wanted to assign the IP address, right, for each and every PC if you manually assign IP addresses, then it will be very tedious task, right. And also for if you see for the troubleshooting part also, it will be a very tedious one to find out the errors and then to solve that particular error to that particular PC, to that particular end devices, right. So it will be very tedious task, right. So in order to solve this particular issue, right, we are going to use this particular DHCP part, right. So here so if we here I'm using this particular DHCP server, so through that if the end devices are wirely connected or wirelessly connected, right, so whatever the type the internet networking devices are connected with that particular server, right, the automatic IP addresses would be assigned to all these PCs, all the end devices, right. So and if the IP address is conflict in the devices, right, so at that time also it will be very efficient to check that particular conflict with the help of that particular DHCP, right. So which is the not part in the manual assignment, right, or we can call it as a static assignment of IP addresses to all the end devices, right. So this is the problem statements, and what we have removing the obstacle for assignment of IP addresses in this particular practical session, right. So if you see, I have created here one of the topology, right. So same topology we need to create on a Cisco packet tracer, right. So for this particular topology I have used this one server is there, one switch is there, and one router is there, and 4 end devices I have connected to this particular switch, right. So we will see how to configure all the components, how to assign the IP addresses, how to configure this particular DHCP server, right. So we will start with the first of all the theory part of DHCP, right, with the help of some manual, right. So we will start with that. So if you see the theoretical part for this particular DHCP, right, so it's an application layer protocol, right, the layer number 7, right. It is a network management protocol, right. So DHCP server will dynamically assign the IP address as we discussed, right. So if you see what are the different advantages, right, so it will be centralized management of IP addresses, right. So you can use a DHCP server pool, and from the series of the IP addresses whatever you have given in that particular DHCP server, right. So from that according to the request you can directly randomly you can provide the IP addresses to that particular client, right. Then it will be easy for adding a new clients to a network, right. So it will be very easy, because if the range you are giving is a maximum range, right, and if you are again adding some of the more clients to that particular, that is also the scalability of your network, right. So if you are adding some more clients to that particular network, so again the DHCP will dynamically assign the IP addresses to this particular that particular clients also, which you are going to add it in a new as a new client, right. And then reuse of IP addresses, which will be reducing the total number of IP addresses that are required, right. So the IP conflicting also it will be checked, right, it will be given, so accordingly that you can use this particular DHCP also, right. So reconfiguration of the IP addresses space on the DHCP server without needing the reconfiguration each client, right. So in this case you not need to reconfigure each and every client according to the IP addresses of that, right, because the DHCP server can manage all these things, right. Okay, then these are some advantages over the DHCP server, right. So we will see, so here if you see the DHCP server is there, then from the router it will be assigning all the clients, and this particular DHCP client is asking for the IP address, and the DHCP server will provide the IP address to this particular client via this particular router, right. So DHCP you can be configured on this particular server itself, right. So we will see how to configure and how to design this particular topology over here, right. So I will just move towards my I will just explain first of all this thing, what we are going to give step by step in on a Cisco packet tracer, right. Then we will move towards the Cisco packet tracer implementation part, right. So in a working area of that particular Cisco packet tracer, what you need to do is you need to just drag and drop one of the DHCP one server itself, right, then one switch itself, one router itself. So here I have drag and drop the 1841 router of Cisco, right. Then end devices, as I have drag and drop the 4 end devices from my end devices component right here, right, and I have just gives the connection to this particular all the components to this particular switches, right. So if you see the FA0/1, that means I have connected the first port of this particular switch to this particular PC0, then the second port of the this particular switch I have connected to the PC1, likewise the PC3, PC4, and this is nothing but the PC3. This is your FS0/6, right? So in this way I have connected the straight through cable to all the internet working devices here, right? After that, if you see, I am configuring here the router, right? First of all, right? So this is nothing but the router, right? So for configuring it, what you need to do is just double click on this particular router, right? So this particular window will open. Okay, in that particular window you just go to this particular configure tab, right? And after that you need to provide here the IP address to this particular router itself, right? So you need to identify what is the IP address of that particular router, right? So I am giving here just randomly the 10 series IP address to this particular router as 10.0.0.1, right? And the subnet mode obviously it is a class A, so 255.0.0.0 it will be assigned as a subnet mask to this particular router one. Okay, and after that assigning an IP address to that particular router, I will go forward to this my particular server, that is I have inserted here as a one server. So I just double click on this particular DHCP server, right? And I am just going into the desktop option of that particular server. If you see server 0, I am going into desktop option, right? And here I am giving the static IP address to that particular my server, right? So here I am giving 10.0.0.10, right? And the subnet mask will be the class A, again 255.0.0.0 as default gateway, that is I am giving here the my router's IP address, right? So whichever I have configured router just now, right? So whatever the IP I have given that to that particular router, that same IP I am giving here in default gateway, because I wanted to pass the traffic from that particular router, right? So I am using here the router as my gateway for my this particular DHCP server, right? So for that default gateway will be 10.0.0.0.1, right? And after that, if you go to the services tab of this particular same server, right? So you will find out here there are different services are listed over here, right? So HTTP is there, DHCP is there, TFT, DNS, on all that things, right? So after that you need to configure that server as your DHCP server, right? So for that you need to just click on this particular DHCP tab, right? One second. Yes, you need to just go into this particular DHCP tab, right? And after that just click on the services should be here on, right? Because you need to configure this particular DHCP server, right? So this particular DHCP server it must, the interface of that particular DHCP server must be on, right? So you need to click on here on, right? The pool name, whatever the pool name you wanted to give, you can give, right? Then the default gateway, again I am giving here the my router's IP address, right? Because routers I am using here as a router as a gateway, right? So router's IP I am giving here as a my in my gateway, right? Then the starting IP address of my DHCP pool, right? So what I need to do is I need to configure here the DHCP server pool. Why? Because within the that particular range itself I need to assign an IP address whichever the end devices are connected to my particular network, right? So for that starting IP address I am giving here 10.0.0.11, right? Subnet mask again for the class A, right? And maximum number of users you wanted to attach to that particular DHCP tool, right? So so I have just giving here the random number, that 512, right? So after that you need to just click on the save button, okay? So in order to save this particular DHCP server settings, right? So after clicking on save, you will find out here the review of your whatever you have done with the settings of this particular DHCP server, right? So pool name, whatever you have assigned, the default gateway is nothing but your router's IP, then the starting IP address range whatever you have given to this, right? And the maximum user, that is nothing but the 512 I have given here, right? So up to the 512 users my this particular server DHCP server pool can be used, right? So whenever I am requesting, right, to any to that particular DHCP server, right, so it will be get accept the request and provide the IP address from this particular DHCP within this particular range itself, right? Then I am going to configure this particular my now itself I have configured this particular router, right? then this server also I have configured out. Right now there is an remaining part, that means this all the PCs, right, all the end devices, the 4 end devices, PC0, PC1, PC2 and PC3, right. So 4 end devices I need to configure, right. And for that what I need to do is, again I need to click on the double click on this particular icon of that particular PCs, right. So so if you see in here also, right, for example PC0 I have double clicked, right, and this particular settings will be open, right. So just go into the desktop tab, right, and just press here the DHCP, right, because I don't want to enter the, or I don't want to give the IP address manually to this particular PC0, right. So if you wanted to give manually, then you need to use this particular static part, right, but I need to give a DHCP, right. This particular PC0 must get IP address from that particular DHCP server itself, right. So that's why I'm choosing here the DHCP. Okay, so it will be directly taken the IP address from my DHCP server. If you see here 10.0.0.13, right, so it will be in a range of 10.0.0.11 after, right. So it will be taking IPs from that particular DHCP server, right. So likewise I need to do for all the PCs, the PC0, PC1, PC2 and PC3, right. And after that I need to check to ping from each and every devices to each and everything, right. So whether the IP address which will be got by this particular internet networking devices or not, or whether the communication will be happened or not, right. So by pinging I am going to check all these things, right. So let's go with the Cisco packet tracer part, right. So we will be doing all this hands on with the Cisco packet tracer, how to configure, right. So let's go with that. Okay. Okay, so if you if you see in this workspace, right, of the Cisco packet tracer, right, so I have created the topology whatever I have explained you in this particular experiment, right. So I have drag and drop one switch from this particular switch boxes, right. So that is 2960 switch I have drag and drop. Then the server which will be available on your end devices, right. So this particular server also I have drag and drop here, right. Then the PCs, number of PCs I have drag and drop here, right. And after that, by using this particular copper straight through cable, right, I have attached to from this particular switches to each and every devices, right. So this is topology which I have created, right. And after that whatever I have shown you, right, so just double click on this particular router part, right. If you double click on the particular router part, go to the config, right, and if you click on this particular fast ethernet part, right, so there is an IP address is mentioned, right. So that this particular IP address you need to give in this particular 10.0.0.1, and subnet mask is again 255.0.0.2, right. Likewise you need to give okay, wait a minute, I just show you. Okay, so if you see here, so what I have done is I just clicked on this particular router number 2, right. So router 1, right. So if you go into interface file, right, that is fast ethernet 0/0, right. So here you need to do is you need to provide the IP address to this particular router, right. So I have provided here the 10.0.0.1 and also the subnet mask for the that is nothing but 255.0.0.0, right. So this you need to just provide the IP address for this particular router, because this router I am using as a router as a gateway for my DHCP server, right. Then again you need to configure this particular DHCP server as well, right. So for that you just need to double click again on this particular server, so you will find out this particular window, right. Through that you need to go to the desktop and the IP address, right? So here you will need to provide the static IP address to this particular server as a 10.0.0.10, right? And again the subnet mask, and for the default gateway you need to write the router's IP address to here, because I am using router as a gateway here, right? So after that you need to go to service tab and just click on the DHCP part, right? Because that DHCP you need to configure for that particular server, right? So you just need to click on this here, the on to that particular service, then what is the name you wanted to give, then the router's IP as a gateway, then the starting IP address you need to provide here, right? Whatever the IP you need to give, right? For example, this IP I need to give, and just click on the save button, right? So it will be automatically saved. Then what you need to do is you need to configure this particular IPs, right? 1 second. Okay, then this particular PCs you want to configure, right? So just go to the PC, click on this particular IP configuration, and just click on this particular DHCP tab, right? So if you go into static, then it won't be used, right? So we want to configure as a DHCP, so just go into DHCP. It will be, if you find here the it will call a DHCP request is successful, right? And it will allocate here the IP address 10.0.0.11 if you see here, right? So which is hidden, right? So our DHCP request is successful, right? So likewise you need to configure each and every pieces over here, right? And if you check whether your DHCP request is successful or not, or whether you are getting IP address for this particular number of pieces from this particular DHCP server or not, right? So how to check that, right? So you just go to this particular simulation part, real time, right? And from this if you see here, the add simple PDU unit, right? So from that PDU you need to check whether the ping is successful or not, right? So I have just pinging from this particular, for example, PC 0 to my PC 3, whether it will be working or not. And if you find here it will be a successful, right? The source will be your PC 0 and destination will be PC 3, and ICMP message I am sending, right? That is I am going to pinging from one PC to another PC, right? So likewise you need to check from each and every connection, right? So from router to this particular server whether it will be working or not, right? From this particular PC to this particular server whether it will be working or not, right? So likewise you will need to check from each and every, right? So you will get it as a successful. Why? Because our DHCP server is successfully get configured, right? And we have successfully able to ping from each and every devices to this particular DHCP server, right? And if you just randomly if you check and the config the IP of this particular systems, right? So you will find if you are enabling DHCP, right? So it will be gives you an IP addresses within the range of that DHCP pool which we are configured in that particular DHCP server, right? So if you again static and make it as a DHCP, then you will see here the requesting IP addresses, and then the DHCP request is successful, right? That way it will be asking for that particular DHCP server, and then it will be returning back the IP address to this particular PC2. That's why it will be given you as a DHCP request is successful, right? So so this is all about for this particular experiment, right? So that's why in this way we have successfully configured this particular DHCP server. Okay, thank you for joining.